In this video, we will talk about thermal expansion. We need to understand this topic of thermal expansion, like how does it work, how does it work in solids, and what are the changes that we might see when there is a thermal expansion in solids. So in order to do that, first of all, understand what is a thermal expansion. So most substances that we tend to use in our day-to-day life are made up of matter. That is, they might be solid, liquid, or gas. Okay, so they expand when heated and contract when cooled. And the reason is very simple. Because you are having a molecules in those matter particles or itself in a matter, so it will simply expand. Okay, because you are increasing the heat. So thermal expansion, you can understand that you are giving the heat. Giving the heat will ended up giving more kinetic energy, and if the elements, not the elements, I'm sorry, if the molecules gets more kinetic energy, they will ended up expanding. And if you have less kinetic energy, like here I can write high kinetic energy or more kinetic energy, so they will expand. Whereas if they have less kinetic energy, they will contract. So since we are talking about expansion, so that's how you can understand the thermal expansion. So thermal expansion refers to an increase in the size of a substance on heating, particularly the solids and the liquids. Gases also will show you the same effects as well, but since gas molecules are very far apart, so you have to see that how it is gonna show you the effect. But in liquids and solids, it's visibly and it's like very easy to understand. So generally gases expand much more than the liquids, and liquids expand much more than the solids for the same rise in temperature. Means the amount of temperature that you will utilize is like equal in both all the cases, which is solid, liquid, and gas. So in gases you will see much more expansion, but as I said, it will be difficult to demonstrate directly, because again you might see the expansion in much more, but in practical life there are very few applications as such where you can actually see them. Whereas solids and liquids are something which we use day to day life and in a lot of things as well, where the expansion is something which can be seen very easily. Okay, now in terms of solids, we are talking about the thermal expansion. So solid has a definite shape and a size. We know that. That is why they are called solid. So on heating, a solid expands in all directions. The another reason is that the molecules that they have are like tightly packed. So they don't have much space which allows them to move here and there. And that is why they start expanding in all directions, like wherever they get the place to just to expand. And that is why their expansion is also small, because they don't have that much of a space. Okay, so a little bit of change in solids can actually easily visible for you, because again the reason is same, because the molecules are tightly packed. And for the same we can do a very simple activity where we can just aim to target the to see the thermal expansion of solids using a bar and gauge experiment. You can see the bar here, you can see the gauge here. So what are the requirements? A metal bar and a gauge and a burner. What you have to do is you take that metal bar and a gauge, okay, and you can see that it will simply fits. It is a perfect size. Now take the bar out and heat it over a burner for a few minutes, and now try to fit it into the gauge. You might not be able to fit it. Why? Because it will expand to all the directions. So now it won't be able to fit properly because its size has been expanded. Okay, so the reason is this is because the bar is expanded on heating allows. So you have to allow the bar to cool down, and as it comes to its normal temperature, it again fits into the gauge, because again it will contract, come to its original position and contract. So your conclusion will be the bar expands on heating and contracts on cooling. So this is like through activity we can actually prove that. Okay, now if I talk about this thing, like if you have different types of solids, so they expand differently as well, depending upon the type of solid that you are utilizing. So when equal lengths of different solids are heated equally, they expand differently. Again, as I said, depending upon the type of material that you are using. Okay. Also, this thing is called the thermal expansion coefficient, like how much heat that you have to provide in order to see the thermal expansion. So for example, what we can simply take here is like on heating equally, the brass expands more than the iron. With this activity also we'll be able to see the same, because brass has more capacity to like allow itself to expand, whereas iron doesn't. Okay, so the thermal expansion of a solid depends on three important factors, which is the original dimension of the solid, like what is the actual dimension and how the arrangement of molecules are there in that dimension, the rise in temperature, what are the temperatures that you are utilizing, and the nature of the solid material. Means the dimension is about the size and the nature is again the arrangement of molecules within it. So with this activity we can actually see the same thing. So our aim is to show that equal lengths of different solids expand differentially, okay, or differently. Now a bimetallic strip of brass and iron strips and a burner, like this is a requirement. So this is a brass strip, this is iron strip, and this is a burner. Procedure is take a bimetallic strip consisting of brass and iron rod of equal lengths, weld it together as you can see in the figure. Using a burner, heat the strip in the middle for a few minutes and observe what happens. You are not supposed to heat on one end. You have to heat it in the middle. So what you will see is you will observe that the strip bends and brass is on the outer side of the curved strip. This is because for same rise of temperature, brass has expanded more than the iron. And if the bimetallic strip is cooled even below the room temperature, the brass contracts more than the iron. So the bimetallic strip again bends, but now brass lies on the inner side and iron on the outer side of the curved strip. So here you can see the curve because you are applying the heat, so the brass is expanding. Now if you take away the heat and put it into something cooler, so it will be like this. Okay, so again the brass will ended up in the lower side. The reason is that brass will contract comparatively to the iron because you are giving the same temperature, you are not changing the temperature with, so with the same temperature you can see such changes. So what would be your conclusion? That for same rise or fall in temperature, there are different solids that expand or contract differentially, and in the case of this experiment, the bimetallic strip of iron and brass, the thermal expansion of brass is greater than that of iron. And you can also say the thermal coefficient of brass, expansion coefficient of brass is higher than that of iron. Okay, so what I can say at the end of that is like why in terms of solid there is so much of expansion. The explanation is the molecular motion, means the molecules that are moving within that. So we know that in a solid, molecules are closely packed and can only vibrate to and fro about their respective mean positions. Means let's say if the molecules is there, so it can move to and fro, that means at its position it can go backwards and forward, that's it. It can't do more because again the solids have very limited space, so they don't allow it to move here and there at all. Okay, so the solid molecules possess vibrational kinetic energy. Rather than simple kinetic energy, they have vibrational because they're vibrating at one point. So when a solid is heated, its temperature rises and so the vibrational kinetic energy of the molecule will also increase. And as a result, the vibrational amplitude, means the overall value of the molecules or overall the movement of molecule will also increase, and this leads to increase in the intermolecular separation between neighboring molecules. So the solid expands in all direction. Means let's say I have two molecules here, they start vibrating, okay, to and fro, vibrational kinetic energy. So the more they vibrate, the more they start hitting each other, so there will be a smaller gap that will about to form. Then slowly if you keep on applying the heat, so there will be enough gap between them, and that's how they are able to separate from each other. And that's how you can actually understand the thermal expansion in the solids on the basis of molecular motion. I hope this topic is clear to you. Thank you.